Welcome to this lesson on two-way tables and probability. Let's get started by my showing you a two-way table. And the title of this table is Concession Stand Sales. And I've given you a lot of data on the table and asking you to write 3 statements interpreting the data shown in this two-way table. Well, there's a lot of statements we could write. I've written one statement that could be obvious to people or not obvious to people. This number 400 in the corner represents the 400 people who apparently bought food from this concession stand. How about you? Can you come up with 3 statements based on that table? Here's a two-way table, shows the responses of girls and boys who were surveyed when asked about their preference of pets. And you and I have to complete the row and column totals in the table. So the first thing we want to pay attention to is the word row and column. So row has to do with going across. So when I add these numbers, I'm going to get 22. When I add these numbers together, I get 28. Which means 22 girls participated in the survey and 28 boys. Now let's add our column totals. 22 of all of the students picked dog as their favorite pet. Fewer students picked cat, and 13 picked other. Now what's very nice about a two-way table is the number here in the corner, which is going to be the total respondents of the survey. You can get that total either by adding down or by adding across. And that'll be a nice check for you to make sure you haven't made an error. Now it's the same data, just written differently. So over in the previous slide, this is called a two-way table of counts because I counted the number of girls who said dog, right? And usually you think of tally marks, right? These are counts or tallies. But over here, the 10 girls who picked dogs, we wrote it as a decimal. 10 divided by 50, remember there were 50 total students, were 0.2. So all of these decimals are the fraction equivalent, 9 out of the whole of 50. And I've done the first one for you, 6 out of 50. I just did this with mental math. I thought of it as 12 out of 100 or 0.12. 10 out of 50 is 20 hundredths or 0.20. Now I think I can add across just like I did before, but this time I'm going to add my decimals. So let's add our decimals. We're going to add 0.24 plus 0.12 plus 0.20. Okay, so that's 0.36 plus 0.20 is 0.56. And that makes sense because when I add these totals in this column, 0.44 plus 0.56 is one whole. And I always expect one whole. So I'm just going to ask you to add your decimals in the column for cat and the column for other, and then double check that when I add these 3 decimals together, I get 1. In this particular slide, you need to complete a two-way table of counts and and relative frequencies. So I noticed that the number 10 wasn't there. I got 10 because I said what number plus 5 equals 15. And apparently we have asked the question, do you have a job? And it's either yes or no. Do you do clubs only, sports only, both, or neither? Okay. And we wonder if there's a correlation between students that have a job and students that answer these questions. Now I'm just going to fill in the missing, right? So the missing here is going to be 6 because 12 plus 6 equals 18. And the missing going across, I'm going to do 51 minus the sum of those 3 numbers. So let's do the sum of these 3 numbers. 10 plus 12, I believe it was plus 9. Let me double check. Yep, and I want to do 31 taken away from 51. That's going to be 20. And now I can fill this out. And I know that 51 plus something equals 75. 51 plus, let's think about that, 24 equals 75. And now I can figure out this missing number. 11 plus 10 is 21. 21 plus 3 is 24. This must be a 12. And as always, we want you to check when you add all of these numbers together, does it confirm the total? 33, 63, 73, 75. Yes. All right, now the relative frequencies. That's when you take your counts of 10 and divide it by 75. We can use a calculator for that. We could round to the nearest hundredth. So it looks like 0.13. We can just double check that when I add 0.13 plus 0.07, I do get 0.20. All right, so now 6 divided by 75. And then I think you understand what to do next. You're going to fill out this table. When you're done, how can you check that your relative frequencies are correct, right? And that has to do with this corner number of 1 whole. I'm going to let you finish that particular slide on your own. Now we go on to a Venn diagram, and I can see that we're talking about golfers. In fact, they're professional golfers. There's 65 golfers who have been surveyed. And we asked them, have you won a major? And did you practice at least 10,000 hours in your career? Okay, and is there a correlation? Well, I love to look at the overlap first. And I look at 37, and I realize that those 37 golfers not only have practiced for at least 10,000 hours, but they also have won a major. Now, these 6 golfers sadly have not won a major, but they also have not practiced for at least 10,000 hours. This 14 is in the category of golfers who practiced for the 10,000 hours but have not won a major. So where would that go? You want to kind of look at your two-way table. They've practiced, but they have not won a major. And look at, now I can add these numbers together. The 8 that I see over here indicates they've won a major, but wow, they must be either really good or really lucky because they have not practiced at least 10,000 hours. Now I'm going to add these together and I get 14. And I'm realizing 51 plus 14 is 65. And the same thing here when we add these numbers together. And I now add my 45 and 20, I do get 65. So I'm confident about my Venn diagram and my two-way table. This word is really important, conditional relative frequencies. So it's not, our whole is not necessarily going to be 50 when we're talking about conditional relative frequencies. Our whole is going to be the number of students that follow the word given. Okay, so let's look at this sentence. Find the conditional relative frequency that a student surveyed prefers cats as pets, given the student is a girl. So this is my whole, because when you look at girl, that's your total. And if that's my total, the relative frequency that out of the 22 girls surveyed that they preferred cats, that's 9. You could write that as a decimal or a percent. I'm going to leave it as a fraction. Now let's see if the next question is asking the same thing or something different. Find the conditional relative frequency that a student surveyed is a girl. Here's my word given. Pay attention to that. Given that the student prefers cats as pets. This time, here's my column of interest. And the 15 is now my whole. And I do have 9 girls out of the 15. And no, these two answers are not the same. All right, on this particular slide, I have a lot of information. I have apparently 91 people I've asked. And I asked them questions like, do you have allergies? And it's either yes or no. How many languages do you speak? And all the people out of the 91, they either speak 1, 2, 3, or 6 languages. And over here, I need to complete this relative frequency information regarding no allergies. So look at 91 is not going to be my whole. This is the column I'm interested in, no allergies. 44 is my whole. And the conditional distribution is of those 44, 28 of those people speak one language. So I do 28 over 44, looks like 63.6%. All right, no allergies. What is the conditional distribution that 2 languages are spoken? If given the person has no allergies. So no allergies is 44. 2 languages is 14. Oh, look, it's half of the 28. So it must be half of this percent. Let's look at it. 14 over 44, 31.8%. You can complete that. And when you're done, we expect that your percents will add together to equal a total of 100%, okay? All right, now we're looking at, I love this question. The question is, if I've asked apparently 100 people this question. First of all, you male, are you female? Okay, so 48 identified, it says male, 52 say female. And then I say, what superpower would you like to have? Would you like to be a fly? Or would you like to be able to fly? That's it. Would you like to be able to fly? Or would you like to make yourself invisible? And all the information is here. So we have to find the probability, and probability is always a fraction. We could also write a fraction as a decimal or percent, that a random person that I surveyed chose to fly as the superpower. Well, there were 100 kids in this survey, right? That's my total. And fly, I'm looking at the 38. How about the random student I chose randomly, that this student was a male? Well, male is 48 out of the 100. But 100 will only be the total if there's no condition placed. But in this next one, there is a condition because I see the word given. So what's the probability the student was a male given they chose to fly as a superpower? Ooh, chose to fly. Now that's my total, 38. And of those 38, 26 of them were males. Now, is this the same question or a different question? What's the probability the student chose to fly as a superpower given the student was a male? Oh, given the student was a male, I'm now looking here at the 48 is my total. And the probability that the random student I asked who was a male chooses fly as their superpower is 26. So it's the same numerator, but it's a different denominator. So these are not the same probability, right? So therefore, in general, the probability of A given B is not equal to the probability of B given A. So this is a false. And the last 2 slides are just summary slides, and I'm asking you to identify your understanding of each of these concepts that we briefly reviewed. You're going to drag over your marker to either solid or confused about this or somewhere in between for all of these concepts. And over here, you're just going to write something you learned and a question you have.